Okay, so I'm going to try to show you the difference between a linear equation and a nonlinear equation. Okay, and I'm going to show you how they look both as a function table and as a graph. All right, so let's say that I gave you this. Let's say I gave you this equation. Let's say that we had y is equal to x plus 2. Okay. And then we'll also say that we have the equation y is equal to x squared plus 1. Okay. And we're going to make these both into function tables. We're going to graph them, and then we're going to try to decide whether or not they're linear or not or nonlinear. Okay. And so let's start with this one over here. We'll make our function table. We've got x plus 2, and then we have y. And we're going to make our function right here, function table. So we've got, let's do -2, -1, 0, 1, and 2. And again, we're going to plug in x into our equation. So we have -2, our expression really, -2 plus 2, right? And then we have -1 plus 2. We have 0 plus 2. We have 1 plus 2. And then we have 2 plus 2. -2 plus 2 gives us 0. -1 plus 2 gives us +1. 0 plus 2 gives us 2. 1 plus 2 gives us 3. And then 2 plus 2 gives us 4. All right. Now let's graph this real quick. So we're going to start, remember, this is our x-axis. This is our y-axis. And then on this side, we have positive numbers, positive integers. And then this side, we have negative. Up here is positive, and down here is negative, right? You think up and down, right? You got positive and negative that way. We're going to start at -2, 0, right? So this is these two columns give us our coordinate plane, right? Our coordinate values, right? That we can use our ordered pairs. -2 up 0. So we're actually just going to start right here on this axis, on the x-axis. Then we have -1 up 1. We have 0, right? This is our 0, this is our origin. 0, +2, 1, +3. We have 2, +4. Okay, and we can make our line, right? We can make our line like this. If we just draw that line continuing through, right, we're going to end up with a line that looks like this, right? And then that gives us y is equal to x plus 2. All right. Let's do the same thing over here, right? So we have our x, we have x squared plus 1, and then we have y. We do this in a different color. Well, we can do it in the same color, I guess. I like different colors though. And then we're going to take our line and draw it through here. We're going to stay with the same values. So we've got -2, -1, 0, 1, and 2. We're going to have -2 squared plus 1. We'll have -1 squared plus 1, 0 squared plus 1, 1 squared plus 1, and 2 squared plus 1. Okay. -2 squared, right? We take 2 times 2, and since it's two negatives, right? Negative squared times 2 gives us, negative squared, -2 squared, there we go. -2 squared just gives us 4, plus 1 is going to give us 5, right? Because you have -2 times itself, right? So 2 times 2 gives you 4, and then you had that positive or negative and negative, which gives you a positive. -1 squared just gives you 1. 1 plus 1 gives you 2. 0 squared is 0. Plus 1 gives you 1. And then over here, you have 1 squared, which gives you 1, plus 1 gives you 2. 2 times 2 is 4, plus 1 gives you 5. Okay, and you can kind of see this pattern here between 1 and 2. Okay. Oh, there we go. All right. So we can start here, and then we're going to graph, right? So we're going to graph this. We have, starting out, we have -2, -2, +5, 1, 2, 3, 4, 5. So that's all the way up here. Then we have -1, +2. We have 0, +1, 1, +2, and then we have 2, +5. Okay? And then we can actually graph this, right? So we're going to take this and try to graph it up like this. So we're going to kind of get this parabola here, right? We're going to get this parabola here. And we're going to just be left with that, okay? And that's good. We like that. So we're going to have this parabola here, right? And then what you can see here is that there are 2 different functions. One of them looks like a straight line, and then one of them looks like this weird kind of U-shaped, right? And we call that a parabola. So I want you to decide which of these is linear and which of these is non-linear. And when I mean linear, right, we're talking about linear functions versus non-linear, right? And if you take a look at how linear is spelled, you'll notice that this line pops out in linear, right? So you can think, well, which of these makes a straight line? Okay, well, that happens to be this first one, this y equals x plus 2. So this is linear, and this one does not make a line, so we can assume that this is a non-linear function. Now, it's not quite that simple, right? If it could be linear necessarily, but what a linear function does, okay, is it is essentially any function that has the same rate of change. Okay, so it's any function, or I guess you could say equation 2, with a consistent okay, rate of change. Okay. Now, a nonlinear function is any function that does not have a consistent rate of change. A consistent rate of change. Okay. Now, what exactly is a rate of change? Okay. Now, a rate of change, the rate of change is essentially how far a line or a function travels over a certain period or distance or unit. Okay, we can also consider that to be the slope. So if you've seen this before, this can also be considered the slope of the line. Okay, but essentially it's something that we call the rise over run. Okay, so it's the rise over the run of the equation, okay, or the slope, right? So let's look at this blue line, this y equals x plus 2, and you'll notice that this line has a very consistent slope. It doesn't change at all, and if you'll notice, right, for every one distance that it goes to the right, it also goes up one distance to the left, or excuse me, to the up. Just so when it goes right, it's going to go up 1. So this is 1, and that's 1. And it's going to do this for the rest of the line continuously forever and ever and ever, and it's never going to change. Okay? So this one actually has a slope of 1 because this has a coefficient of 1 on the x. If you look over here, right, from this point to this point, from -2 to -1 on the x-axis, right, this drops 3. This drops this 3 spaces here. But then if we go from this -1 to 0, right, this only drops 1. So this has a -3 and a -1 drop. This guy then goes up by 1 when it travels 1 over, and then it goes back up by 3. So not only does the slope change because we start at negative, right? It's going down, it has a negative slope, and then it's going up into a positive slope, right? The steepness rate also changes. Okay, so how fast it falls or rises also changes. Okay, so this is a nonlinear function because it does not have a consistent rate of change. Okay, so for example, the rate of change for the blue equation was 1 over 1, and it's going to stay that way forever. Okay, so a linear function is anything that has a consistent rate of change, whereas a nonlinear function does not.